Hi there. Well, today it's much of what we were doing last time, to be honest, only we're just looking at something called a one-tailed test. So last time we were having to choose between either end. Today we're just looking at what happens if you want to know whether or not something is more than or less than a certain thing, and checking out to work out your critical region and making what things you can from there. I have to admit I've left my calculator somewhere else, so I haven't got it today, but I thought it was a good idea to make sure that we can use the tables as well. Now, if you don't want to use the tables and you can remember what you're doing well enough with your calculator to do that, that's fine. But it's good to be aware of how to use the tables, because sometimes they can be a little bit quicker. Right, so here's our first example. You've done enough of these now to probably be able to have a little go and see how far sketch of what's going on. So, because of a 2/5 chance of success, 40% of the time it's going to be peaking before halfway along, isn't it? We've got 20 patients. I'm going to put a 0 there and a 20 there. And this doctor is claiming that things have got better. So we are therefore looking at this end where more people are going to be getting better. So we're wanting the region up here that is going to be 5% or less, so 0.05. How many do we need to get to that? And is 11 within that zone? So we're testing at the 5% significance level. Let's just remind ourselves of a little bit of notation we could be putting down. They haven't asked us for it, but it's still a good idea. We could be saying that our x is going to be represented by a binomial with 20 tests, and our probability is 0.4. And we haven't been asked about hypotheses, but the null hypothesis would be that it stays the same as what it was, even though that's not what the doctor wants. So the null hypothesis would be the probability equals 0.4 or 2/5, doesn't matter. And the alternative hypothesis would be what the doctor's saying, which is that it's better than 0.4. Now 11 is more than half of the patients, isn't it? So it's possible that we're going to get a negative result about this, and yet that this drug is a bit better, but we just don't have enough evidence of it yet, and that's the point. Is there enough evidence to support the claims? And I've got to admit, I'm thinking it's a little shaky. I mean, 2/5 of 20 is 8, isn't it? So 3 more patients, I think that could possibly happen even if it hadn't got any better. But let's have a little look. So the first thing to do would be to grab your tables, starting here at section 5, it's on page 29. Now we want, n equals 5 means 5 trials, so we want 20 trials, which ends up being here. And the probability is at the top of the page all the way up here. Now we're going for probability of 0.4, so that third column from the end is what we're interested in, so let's keep an eye on that. And we're thinking about 11 or less. Now it's tempting to go along the 11 column, but actually that's telling you 11 or less, but sorry, we're not thinking about 11 or less, are we? We're thinking about at least 11 patients. So this 0.8725 on 10 is telling us that the probability of getting between 0 and 10 is 0.8725. That's the one that we want. I'll explain why in a moment. So the reason is the probability that x is more than or equal to 11 is going to be 1 take the probability that x is less than or equal to 10, and that's the one that the table gives us. That's the point. So it's 1 take 0.8725, which is 0.1275. So that's 12.75%, which is some way more than what we need. we would actually need it to go up a couple further before we're going to get to the point where we could say that there's a 5% significance level. We're not even into the 10% significance level yet. It could be better, but we don't know, would be the final thing. So we should just write something about that. So I've put in, there's insufficient evidence to support the doctor's claim that the new drug is an improvement at this level of significance. If I only wanted a 20% level of significance, I could say, yeah, maybe it does. But that's not actually enough for any serious doctor to consider that to be good. Right, I'm just going to give you 2 more of these to have a go at. So pause the video and give this a good go. So the test statistic will be the number of voters that say that they will support it, will support the candidate. And the null hypothesis will be the one that supports the 35%, and the alternative hypothesis will be one that's saying it's more than 35%. Now, finding the critical region using the book, this is where it can be a bit quicker actually, because what we're looking for is we're thinking about where that region is. Sorry, if I start again. We've got our candidate being at about 35%, so it's going to look similar, and we want to know what's going there. So it's going to be 95% or more there, 5% or less there. That's what we're looking for. And this table tells us from 0 up to however many we've got, doesn't it? So we want to know number of trials 50, we've got probability of 0.35. Now we need to get this probability from 0 all the way up as far as 95%, so 0.95. Now if we look on here, it gets to 9290 at 22%, so that's nearly enough. And then at 23, the 23rd person knocks it up to 9604. So at that point or less, if you've got 23 or less, suddenly we're okay. Now does that mean the 23rd person is in the region? It doesn't, because that 23rd person is making that jump up to there, isn't it? So it's only more than that that we can be happy with. So what I'm writing down is, I'm using my binomial of 50 at 0.35, and I'm saying, right, the probability that x is less than or equal to 23 is 0.9604. So at that point, the other bit is less than 5, and the other bit includes 24 upwards. So the critical region is 24 to 50 voters, or 24 above, or you could say above 23. So the final thing, in the new poll, 28 people are found to support the candidate. Comment on this observation in the light of the critical region. It's in the critical region, therefore what we can say about that is that using the 5% level of significance is enough evidence to support the organisation's claim that the candidate's support has been increased. Okay, here's your last question. Pause the video and give this a go. You may have recognised a fair amount of similarity with the one before, with the first example that we did. So we've got our binomial, we've got 20 trials again, we've got the plant germinating 0.4 times again, and we are looking at the same idea up here, aren't we? So we want that to be 5% or less. So finding the critical region is just a case of going back again to finding where n equals 20 and it's 0.4. We got down here, didn't we? This is where we were with 10. We need to get into that point where it is into the less than, so here we go at 9790, which happens for 12. So 13 or more is going to be okay, because 12 is the point that it happens at. So if we put all of that down again, we get 0.7990. So our critical region is going to be just one more or any more than that, so at least 13 plants. And then to comment on this observation here, we can say there is significant there is sufficient evidence to reject the hypothesis at this level of significance and back the claim that the horticulturalist has developed a better technique. And that's it for today, and we will see you next time when we will have a little look at two-tailed tests, when we start to put something at the other end, and we split our 5% into 2.5% at one end and 2.5% at the other end. Okay, cheerio.